Sometimes they do.
No, because Chase would turn to Anthony for help, and then Anthony's like, "Oh, if you want to help you, you have to pay me." And then Chase would just turn back to me. He's like, "Kelly, can you help?"
See, you have flaw. You break the market.
I had no house homework for 2 days. Like, what else am I supposed to do in my life?
Go home.
Enjoy
I didn't
life.
go to school for the past 2 days, but I went to Starbucks right now.
And you did math?
Well, like, I would call my phone, and then I would help them whenever they asked.
Really?
All right, so we're gonna go through this.
My parents are not home after sure. No, you know, the past 3 days,
All right.
I have not seen them that night.
Kelly. Shh. All right, we're gonna talk about power series. Garrett, we're gonna talk a series with a variable x that okay. That is raised to some power. So this is a very important start point. I think this is and this is about have a major shift about how you learn stuff now. So this is power of n. And I'm going to give you a representation of power series. This is the first representation. N equal to 0, infinity a to the n, x to the n is equal to a to the 0 plus a1x plus a2x2 plus a3x3 dot 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 dot. Because n is equal to 0, that's going to be 1. Okay? 2. Sometimes you can have power series with different thing, which is 0, infinity, a to the n times x minus c to the n. The only thing difference between those two is the x minus c part. Okay. So this is two type of representation of power series. Later on, this representation is very similar that the center at C, there is a something called Taylor series and Maclaurin series. One Maclaurin series is center at 0. Taylor series it can be center at anywhere. So it's very important for you to know this. So the only thing difference is this part. We have a series of summation a to the n before. We never have a series with a to the n and have some type of x to some type of power. This is the first time we ever have this. We have all kind of series with n factorial over n to the n power, n plus 1 over 2n minus 1. And you have all those series. We can test convergence. We can use a lot of different type of convergence tests. We can have geometric, telescope. Just so you know, on AP exam, telescope is least likely to test. Geometric is most common. AST is most common. So geometric, AST, P series is the 3 most common series to test. Direct comparison, lemon comparison test is also tested, but those 3 things were always tested. Now, power series is the first time we introduce a variable into a series. And you're gonna be like, well, what's the difference? Now you have x to some type of power. Now, what the nice thing is, I'm gonna ask you guys to write down the first few terms of power series. N equal to 0, infinity, -1, to the n, x to the n over n factorial. And then you're gonna write down first few term. You're gonna write out first few term on this one as well. You're gonna practice writing out the series because you're gonna do that a lot later. This is 2m plus 1 over 2m plus 1 factorial. Custodio is gonna be mad at me.
Is your birthday?
She's gonna report me too.
What's X?
Huh?
What's, but like it's actually, is it just X?
Yeah, just x. So the first term is going to be -1 to the 0, which is positive, and x to the 0, which is 1, over 0 factorial, which is 1, right? Which is 1 over 1. Minus x to the 1 factorial. This is not factorial. This one's 0 factorial, so it's 1. Plus x squared over 2 factorial minus x to the third over 3 factorial plus x4 over 4 factorial. And let's keep on going. So this is some type of power series. Now you can have another one, which is -1. No, this is -1 to the 0 power is 1. So it'll be x minus pi over 4. If I plug in 0, it's going to be to the first power over 1 to the factorial. Plus x minus pi over 4 to the plugging 1, so it'll be 3 over 3 factorial because they are the same number, plus x minus pi over 4, 5 over 5 factorial. And keep on going. So this is a representation of power series. What's the difference between those two power series though? Like what's the major difference?
On the bottom, this is supposed to be alternating.
Yep, you're right. Is second one is negative.
And that's a two-way the exponent on the right. It's x minus pi over 4 to the 2n plus 1.
Yeah. 2m plus 1 here because that's what it's same as a bottom number. So what's the major difference between those two? Which constant are you talking about? Pi over 4. So that is called x equal to pi over 4. X equal to 0. So the center who has x equal to 0 and x equal to pi over 4. This center is really important. I didn't understand how important is the first year I taught them. But it's very, very important because that is gonna dictate later on what we're gonna say. Now we just show you a two representation of power series. First time we introduce x into a series, and the x can go to the n power. has to be x to the n powered. So 2n plus 1 is fine. 2n is fine. 2n minus 1 is fine. 5n is fine. Doesn't matter. As long as it's x to some type of power. And this power series, now this is a main interesting part of this, creates functions of x f of x is equal to summation of n equal to 0, infinity a to the n, x minus c to the n. Now, what I write down here, the only big difference between what I write down here is I add additional f of x. And this f of x is a game changer because I can take this power series and use that to represent a set function. Even though this is a power series, just something keep on adding, it go to infinite amount of time. Now, with a particular domain of all x such that the summation of a to the n x minus c to the n converge. But you gotta realize something though. Not all value of x converge. And I'm going to give you an example of this. So the one example that I'm going to mention, I'm going to say this again. The power series create the function of x. So we represent f of x into some type of power series.
I've got 3 questions left, but I suddenly have to take my mom to the airport. So I can't do them anyway, but
Yeah, I think has to be done now.
she
Well-
suddenly has a flight of 4, so yeah.
Yeah. Well, those 3 are
I was probably gonna get them wrong anyway.
right there. Interesting, child.
Like what class did you
Okay, so very important you understand this. Not gonna work for all x value, but in some work for all x value. Some work for a range of x value, but some can only work specific points. But in many cases, they can represent as a function of f of x. And that's something that's very important for you to understand. So the first example, which is, it's very, very interesting, is summation n equal to 0, infinity x to the n. Can you write down the first 4 terms? Very easy. What is first term? Plus second term. Plus x squared plus x to the third plus x to the fourth, and keep on going to infinite amount of range. The thing is, what kind of series is this? A P series? No, not P series.
What? Geometric arithmetic?
What do you say first?
It's one of those two.
What do you say second?
Well, you gotta figure out which one.
like an inverse. Oh wait. It's arithmetic. No, it's geometric. Geometric. Final answer.
Final answer, $1 million.
Geometric, $1 million geometric.
You got $1 to bet.
I have like
Gentleman's bet.
we do a cough drop if I'm wrong.
I kind of need a cough drop.
Geometric.
Geometric. But I don't deserve one though. You got it right.
Got me.
Why is geometric? Because each time of the things is multiplied by what? Multiplied by x, right? So x times x times x times x times x. So the thing is, here it says, what can you do to make this as a function? Is it possible for me to represent 1 plus x squared plus x cubed plus x to 4 as a function? No, not x to infinity. Something that we learned that we use on the test, and no.
Which one is this?
Yeah. I'm only representing 1 plus x.
Since it's geometric, that's your clue.
And what's the rate? It's geometric and
Ratio, not rate.
ratio.
There's a ratio.
I'm a ratio.
Uh, 1 over 1 minus.
There you go. So this R represents X if it's geometric. Then can I just write down A over 1 minus R is equal to A is 1 minus X. But with a one domain. Can you tell me what a domain? What's geometric domain? The absolute value R must be what? Less than 1. And if that's less than 1, that means your domain must be less than 1 as well. And that's going to be 1 less than x less than 1, negative 1. So this means 1 over 1 minus x is equal to summation of n equal to 0 of x to the n to infinity. I'm just going to write out the other side. 1 plus x squared plus x cubed. But this is known as f of x. Now this part start forming the connections. So that means summation of n equal to 0, infinity, xn is actually represent f of x equal to 1 over 1 minus x, but only restrict within the interval of -1 to 1. Which is super cool, because if you don't believe me, think about you between -1 to 1. Right? Can you give me a value, Jared? 0.99. Okay. So 1 over 1 minus 0.99 is equal to f to the 0.99, right? That's also equal to 1 plus, what is it? 0.99 plus 0.99 squared plus 0.99 to the third. Now this one's kind of hard because you're gonna have to keep on adding, but you know that at the end it's gonna be 1 over 0.001. That's equal to 100. Now, if you don't believe me, we can say, well, how about 0.99 to the 100 power? Right? So 0.99 to 100 power. To the 100 power. It's gonna be really much smaller than this, and you're gonna add all this. But here's the things. What we're gonna do is we're gonna show you the representation of this, and we'll start with something that half will be easier to define because we can see that if it's a half, it's 1 minus 1 half. It's equal to 1 plus 1 half plus 1/4 plus 1/8 plus 1/16. Do you see that thing? Jared, do you see it? Now, we're going to show you that's true too, but give me a second. What we're going to do, we're going to use decimals to create this, right? And the decimal says f of x is equal to 1 over 1 minus x. And the only work on which interval? From -1 to 1, so it's going to be here. From -1 to 1. So only between this interval here, that it's gonna work. Any part else doesn't work because I'm gonna say 1. We're gonna say g of x here. G of x is equal to 1 plus x. Do you see that? Plus x squared plus x to the third plus x to the 4 plus x to the 5 plus x to the 6. It's getting there. Plus x to the 7 plus x to the 8, and we're going to stop at 10, plus x to the 9, very close, plus x to the 10. So it turns out the more iteration I'm continuing, the more exact it's going to be represent between -1 to 1. Now, Marcos from last period posed a good question. I want to see the moment it failed. So we say let's change that 1 to 2. Change this 1 to 2 and see what happened. Because changing to 2 automatically doesn't apply because that's on the other side already. And automatically, if I change to this side to -2, you're going to see it doesn't work anymore. It only works between -1 to 1 and strictly, and the center has to be at 0. Because this equation, this power series, is centered at 0.
What's the vertex of the
Vertex?
yeah,
Like this part? I don't know.
yeah.
Maybe like here. It doesn't have a vertex. Oh, the other one.
It's gonna keep on going.
This one.
Why, like,
But it's gonna be more accurate as it keep on going. Because this, if you do 100 iteration, can probably go to -1 to 1.
no,
1,000, the more iteration, the more accurate it's going to be.
so like the negative 0.7 plus x to the 11th, that would go further negative.
Yes,
Approaching.
yes, it will be further more accurate.
Would there be bounds for the solution?
Huh?
Would there be bounds?
What do you mean bounds?
But it's just from 0.
Only for -1 to 1 works. No other places work. So,
Yeah.
like this is my head. This is the center. This is 0. It work here. It work here. That's only where it defines Mr. Ye. Anything else it doesn't define because this is my range. Anything outside of this, it's not me. Does that make sense? This is my center. This is called center of convergence. And this is called interval of convergence. This is interval. You got a center, you got interval.
It's the center 0.
Center's at 0 in this case. Okay, so let's just say f of 0.99. So f of 0.99 here, even though it's not going to be super accurate, but 0.99, it's already 100. Okay, so let's say g of 0.99. It's probably not there yet because it's more accurate it goes. So let's try to add more. But if you do, let's say, because you do it toward the end of the spectrum, so that's a 0.7 will be probably better. So that will be pretty better accurate. And we are talking the only 10th iteration now. We're not talking about this is infinite iteration. Infinite iteration, even at 0.99, it's gonna be super accurate.
And you said this in last week, like this worked for the derivative also. Like,
Yeah, it technically it does. And that part I haven't tried on decimals yet, but let's try it.
Wait, yeah, so can you graph f prime of x?
Let's do that.
Yeah. Let's see what happens.
Okay, so
Second one.
f prime of x, which is here, right?
Like
And g prime of x. And this is later we're gonna deal with. Yeah, it's pretty accurate, but the radius convergence is still around the same region. So, and you can actually take integral on both sides, which is
yeah.
still like pretty cool. Like there's a lot of equation that you can manipulate. You can manipulate to any type of function just by adding one, subtracting one, integrate on both sides, derivative on both sides. You can actually come up all different kind of sort of equation. Like the possibilities is different each time. So it's you can integrate the sine of x to cosine of x, and you can, this will always hold true too. It's very, very interesting. We're gonna do a lot of practice problem, and it's gonna work. And they even show you like you have to show the ideas. But yeah, so I would say this is a beginning stage of power series, and this is what we're gonna do for the next whole week, which is Taylor series, power series, Maclaurin series, which is the main meat of Calc 2.
All three of them.
We're going to talk about all three. Power series, Maclaurin series, we're going to talk about. Power series, just the starting building block. And the Taylor series is how did Taylor come up a way that to represent any functions. Any functions. So it could be work with e to the x, sine of x, cosine of x, natural log of 1 minus x. Well, natural log of 1 minus x is actually not hard because you can actually take this integration. It's pretty close to that. It's just going to be negative of natural log of 1 minus x.
I'm gonna try to ask this properly. So you know how some functions have holes, like some rational.
Mhm.
I think they're called rational. Yeah.
Mm-hmm.
Like how could a hole be represented if you're just adding polynomials? Does that make sense? Like if you're just adding x plus x squared plus x cubed. Like how could you get a whole from? You see what I mean, Anthony? Do you understand what I'm saying?
Yeah, but the whole can be it probably can be restricted by your radius convergence.
Okay.
It's only represent because they only can, so even this function, let's say 1/1 minus x, it cannot represent the whole way. It can
Yeah.
only be represented between this interval to this intervals.
Exact. Is it exactly the same or is there
In the small amount of interval. Usually small amount of interval. Some function can be infinite amount of interval. Some functions.
Yeah.
There are some functions, the radius convergence is negative infinity to positive infinity. Some function only can be represented 1 point, which is center at 0. That's it. There's no other things. Some function has a interval of convergence. And that's what we're going to do is Monday, we're going to find the interval of convergence. Like if I give you a power series, can you tell me from where it work? It does not tell you say anything else. Is sometimes it could be the first scenario is only 1 point at work. And only can define 1 point out of this
That's fine.
the infinite amount of time. Second thing is could be negative infinity to positive infinity. It works on everything, long as you do infinite iterations. The third thing is gonna be usually an interval from 1 to 5, which is center at 3, and it has a radius of convergence of 2, and has interval convergency at between 1 to 5. So it could be like this. And sometimes you have to discover are the endpoint, are they converged or not? Because sometimes one endpoint is converged and the other endpoints diverge, which is kind of interesting too, because you plug in, you'll find out like one work and the other one doesn't. And which is very interesting. But right now, you can represent some function with an interval in term power series. That's what we're gonna get to today.
Do you still have your own?
Mathematician.
Yeah. There was children.
No, it was the sum.
Yes.
I was thinking like okay, for that one, if you divide